Martin. Thank you very much. Okay, so this talk, GNURadio from scratch, is a modified version of one I did at Cyberspectrum, one of the Braun infamous Cyberspectrum, a monthly meeting we do in the Bay Area. And the original talk was 2 hours, so I've done this before, but not in 45 minutes. So I'll try and stay on track. Maybe I'll have to skip over some, but let's go right into it. So, very briefly, I'd like to introduce myself because I haven't had an opportunity to do so. My name is Braun. I've been with the GNURadio project for many years at this point. Among the things that I do within the GNURadio project, I'm the community manager. I also coordinate the Summer of Code. Unfortunately, we didn't have a Google Summer of Code this year, but we did have a Summer of Code in space. And the student that we had for that project will actually be here at this conference, which is very nice. And we have a working group, community, and user experience, which I also organize. So this is kind of in the same vein. I'm also a UHD developer, but that's kind of like the point of this presentation. So and for this presentation in particular, I would like to make no assumptions whatsoever. I'm just gonna, like, you could be a crowd of interested people that have never even heard of GNURadio, that's fine for this presentation. And I'll sort of run you through, you know, all the major steps that you'd encounter if you started using GNURadio. So what's the relation between this presentation and the tutorial that Jonathan is doing? They're a bit different. I'm sort of going through the whole stack from like knowing nothing to actually writing code, but in a very short time. Whereas Jonathan is actually targeting less than I have, but over a longer period of time and with hands-on, so it's way more in-depth. So I guess if you listen to this one first and then do the tutorial, you'll still get a really good overview, which, well, for the guys that are already over there, they don't get the pleasure. So okay, I just wanted to make sure that I'm not actually assuming anything. So you don't have to know anything, but just out of curiosity, who in the audience has actually already developed with GNURadio? And use it to build applications. Okay, it's about half. So maybe I can speed up the front section, but I don't want to leave anyone behind in this presentation. And actually, so the first thing where people often already stumble over is how to install GNURadio. And I think GNURadio, a bit like Linux itself, has this legacy of like, it's so difficult to install. And I don't know, like there must be a couple of people. I think a couple of people here have, remember the times when you're installing Linux was like crazy complicated, and you had to recompile your own kernels and that kind of thing. But if you do it these days, it's so easy. Like I don't know. Try and install Windows and Linux at the same time. It's impossible. Like just Ubuntu CD, they do everything for you, assuming the hardware is supported. And I think GNURadio has evolved a bit, and it's become very, very easy to start trying GNURadio. And it didn't always be the case, but I'd like to debunk the myth that installing and testing GNURadio is difficult. So the easiest way to actually use it is the live DVD, which you received as part of the registration. Plug it in, it's all there. You just run it, you can try everything. Sure, it's not your own, sort of on your own system. If you want to do that, then I actually recommend that you just simply use your package manager. So this is something that people are still getting used to, but where's my package manager? Somewhere here on one of these desktops. There we are. So this is, oh, it's way too small, you can't read this. I apologize for that. So this is Synaptic, which is sort of the Ubuntu package manager, and what you can't read, but what I tried to do is I filtered for GNURadio, and this is a list of packets, and you'll see it's version 373. It's not the latest version, but it's also not too old. You can definitely work with that. And this isn't even the latest Ubuntu. So you want to install GNURadio? Just do apt-get install GNURadio, or yum install GNURadio, whatever. And if you ever get to that point where the version is too old, then you can still take that extra step and install a newer version. But there's no reason to do that from scratch. I mean, how many people build Firefox from source or whatever browser you use? No one, of course. Oh, okay, well, that's you kind of ruined my ruined my presentation there. Okay, for those people who do want to install GNURadio from source, we have a tool called PyBombs, and in most cases, this will take care of everything for you. You say, okay, PyBombs install GNURadio, and it'll download the latest version, and it'll install dependencies, and there you go. Doesn't always work, and PyBombs has some issues that we're trying to sort out, but it's a very useful tool. So if you're used to package managers for other projects like pip for Python, or npm for JavaScript, or gem for Ruby, PyBombs falls into the same vein. Of course, you can do a source build by hand, like any other open source project, and the source builds have some kind of they had this like aura of being like voodoo, and it's really not that bad. But as I said before, if this is something that intimidates you and you're not comfortable with, you don't have to do it. You can use any of these other tools to set up GNURadio. I just want to plug PyBombs specifically because it's such a useful tool. It was started a while back by Tim O'Shea and Tim Newman, I believe. And the fantastic thing about PyBombs is it doesn't only install GNURadio and the hardware drivers for you, but it also lets you install all the out-of-tree modules like gr-radar and gr-ldpc very easily. So you can just, you don't even have to know where to download them. You can just let PyBombs do that for you. And we are currently rewriting PyBombs. PyBombs 2.0 will be, I don't know, it's still out there, but it has a couple of very, very interesting features that make it very compelling to switch to once we actually have it. First of all, you can just install it like any other tool, so you can do pip install PyBombs, and then you have it available, so you don't have to do the complicated bootstrapping process that PyBombs has right now. And then what's interesting is you can have multiple targets, prefixes we call them, where you install stuff. And one thing that we'll definitely have in there is transparent cross-compile support. So you want to set it up on an embedded device, for example, cross-compiling. You can just do PyBombs install gr-radar, and it will do the right thing to compile it on an ARM board or whatever. And if you're interested in helping out with the development, I've put the URL to the GitHub project up there. Okay, so source builds, I've already mentioned, they have this aura of being complicated. If you're lucky and you have all the dependencies, you can just run cmake and make install, and that's it. Sometimes it fails, but if you've gotten that far and it actually fails or something, then that's a legitimate question for the main list, for example. And I'm going to talk about the community aspect of GNURadio in a minute. Okay, so let's say you've gone through the complicated step of doing apt-get install GNURadio, and you have it running on your computer. What are the resources that you have available? First of all, very obvious, but definitely worth mentioning, the GNURadio Companion. The GNURadio Companion sometimes is actually mistaken for GNURadio itself. It's actually just a graphical front end, but it's so useful. And even if you're planning to do like embedded C++ development with GNURadio, I definitely recommend that you do not skip this and treat it as just a toy or a graphical front end tool or something like that. It is so useful to be able to debug your applications, which are flow-based anyway, using graphical sinks and scopes and having sliders in there. This is like, it's so fast and easy to debug your flow graphs if you have this kind of capability. Now, I'm not going to talk about this in great detail because we actually have dedicated talks on this. So Tom and Tim O'Shea will both talk about various related aspects. So I don't want to talk about this in great length, but just sort of, for those who haven't seen it yet, this is sort of one of the examples that we shipped. This shows how a DPSK modulator works. I just randomly picked one, and so I can launch it. I think I should be able to launch it. Actually, I can. Oh no, it's running in the background. Oh, there we go. Here. And you can see all kinds of things happening. So this is sort of a DPSK modulator. As you can see, the pulse shaping in here, and the spectrum, etc. And so say we had a bug in one of these blocks, like this would be an easy way to figure out what to do next. Okay, CGRAN was already mentioned, is the Comprehensive GNURadio Archive Network. So it's a project with the same vein as the CPAN or CTAN, if anyone knows what they are. This is a website that we recently relaunched, and it currently looks like this. I can just zoom in here. And I'm also not going to talk about CGRAN for the same reasons. I'm not going to talk about GNURadio because Chris actually will talk about CGRAN later. But just to sort of give you an idea of what this does is you can sort of look for stuff, and then you'll find projects, and you sort of click on them, and it'll give you some nice graphics to show you what is going on, and information, how to install it, whatever. And CGRAN and PyBombs are actually linked. So this is good to know, because CGRAN is actually an automatically generated website. So the old CGRAN was sort of hand-generated, and that's why it sort of died out. And if you've never heard of the old CGRAN, don't worry, like you haven't missed anything. But the new CGRAN and PyBombs, they use the same database for what to display. And that's why this is always going to be up to date, because we have to keep PyBombs up to date, otherwise we can't install stuff. Very, very useful. And most importantly, if you're sort of working on a project or a problem, there's a high chance that someone's already worked on something similar, or maybe even the same thing that you're looking for. And this is where I go shopping. Okay, CGRAN. Now, let's say you've installed GNURadio, you've had a look at CGRAN, you've installed one of the examples, and at some point you just want to get actually hands-on and you want to do stuff yourself. You need someone that just explains to you how the first steps are. Like, what do I click? Where do I write code? Where do I add features, etc., etc., etc. And we have a set of tutorials for that. The guided tutorials. So these are officially endorsed tutorials. We put together a task force to write those. They get a lot of attention, so at this point they should be pretty accurate and have very few bugs in there. I'm not going to rule out any bugs at all, but that's the nature of all things. And these really start like this talk with absolutely no assumptions, and you can just have a look at the individual ones. So an introduction to GNURadio is really, really basic. What is GNURadio? Why would I want it? And then even the later ones, programming in Python, for example, will sort of clearly line out what you need to know before you go in there, and then have very, very detailed explanations of what you need to do to get started. Has anyone gone through these guided tutorials in the auditorium? Quite a few. I'm very glad to see that. So how did you enjoy the experience? Was it useful? I'm getting lots of nods. I'm happy to hear that. Thank you very much. Okay, thank you. So the guided tutorials are available on our website, and there's actually a out-of-tree module called gr-tutorial, which sort of provides the examples in there. So you can write it all yourself, which is really the point of the tutorial. But if you're stuck somewhere, there's basically a solution that you can have a look at to help you. And there's also a couple of questions, like we call them quizzes in here, that don't have answers, which is on purpose. And the idea is sort of just to get you interested in thinking about this. So, quiz. What will change if we decide to shift our modulation scheme? This is very, I already found a typo. See? It's good that I pulled this up. This is very sort of digital comm specific, but most of these questions are actually very GNURadio specific. Okay, so at this point, you might have installed GNURadio, you've played around with most of the tools, you've had a look at some of the examples, you've started reading the guided tutorials, and this will give you sort of, at this point, you've probably invested a couple of hours at this point, but that's not too bad. At this point, because at this point, you're really able to start using GNURadio and all its in all its glory and with all its strengths. An interesting question that comes up next is, so there's all these blocks in GNURadio and I can use them and I know how to use them, but only like for each individual block, I really don't know how to configure them. What do the parameters mean? What do they actually do? And this is something where we've spent a lot of time in the recent years to improve our manual. It currently looks like this. So the manual is separate from the wiki page, it's automatically generated from the code and the dedicated manual pages that we throw in there. And I've just randomly opened up a block description, and it sort of gives you a mathematical explanation of what it does. It gives you information that once you become acquainted with the nomenclature of GNURadio, you'll find useful. Like, this is a block, sync block with no memory. If you don't know what that means right now, that's fine, because we have other manual pages explaining what a sync block is. Yeah, so this will explain which methods you can use, getters and setters, etc., etc. So for the individual blocks, this is what it looks like. And if you go back to the top level of the manual, I might have zoomed it a bit much. I do want to make sure that you can actually read what's going on here. So there's several parts in here. If you click on this part, GNURadio usage, you'll find all kinds of topics spelled out. So message passing might seem interesting. Maybe you have a block that wants to pass a message to another block, and you can just read through this. And it's always linked to the code itself. So if I click on this link, for example, it will take me back to the actual API call. So this might seem already a bit too advanced for some of you, but some people might find this very, very useful. And the idea is not to learn everything about GNURadio at once, obviously. You sort of start with basic examples and sort of work your way upwards. And usually what happens is you run into a problem, you say, okay, I figured out how to write an application, but this is one little snippet that I can't figure out. Like, I need to obviously write some code. What do I do next? So in this case, these manual pages will usually be quite useful. Just to point it out, a lot of the GNURadio blocks will provide documentation in here. You obviously can't read this from where you're sitting right now, but this is sort of a basic explanation of what's happening. So if you're in this context and you don't want to switch into your web browser or something, like you'll usually find some basic explanations. Okay, so I think this is a good point, assuming you've gone through the tutorials and you've had a look at the manual, you know where to search for stuff to actually start writing code. So out of those who use GNURadio, who has actually written blocks in C or Python? And who has not but would like to? Yeah, I think you're in the right place right now. So yeah, you want to start writing code. So there's a tool called gr-modtool, and you'd be foolish not to use it. Let's put it this way. It's a command line tool, and people have been asking for a GUI version of this, and I think that's a reasonable request. But someone needs to step up and write it. So, and a good time to write these kind of tools is actually when you yourself, needing them the most and learning how to use these. So I actually wrote gr-modtool myself when I was working on several out-of-tree modules, and it was just so many repetitive tasks. And I decided, like, even if it takes me longer to write gr-modtool, then it saves me time. At least I won't go crazy just copy and pasting boilerplate code. And there we are. That's how that happens. So maybe someone else feels the urge to write a GUI tool for gr-modtool. That would be very useful. At this point of my presentation, I will actually go ahead and write some code just to show you how the process works. And I'd like you to try and follow what I'm doing. I might be going a bit fast because I'm time limited here. But if there's any questions, just interrupt me, and I'll just take time off some other part of my presentation. Okay? So we used to have an example. So this is me on the command line. There I am. You just have an example where we write a block that takes an input, squares it, and writes that to the output. And I'm going to run you through the steps that you need to do this. So, gr-modtool is what we like to use, and we can do gr-modtool help, and then you give us a little description of what it does, and you can see there's a command called gr-modtool new mod or create. This is create a new tree module. Now, our tree module, I didn't actually explicitly point this out, is how we extend GNURadio with our own functionality. So if I go into this view, you'll see stuff like filters and error coding, and these are all elements that come with GNURadio. You install GNURadio and nothing else, you'll have all of this. But at some point, you might want to add your own functionality. So you need to add a module, and these modules are called out-of-tree modules. So let's create one. And we'll just call it con for conference, and then we have one, and it tells me it's created a new module, a new module called gr-con, conveniently. So let's just go here. And we can do stuff like gr-modtool info, and it'll tell me, oh, this is a module called con, and I can, excuse me, and I can add a block now. So I'll do that. And there's a couple of switches, so don't worry if you don't understand all of them. So -t is like what type of block. I'm just going to do a sync block, which is the easiest one. And we explain what a sync block is in the tutorials. But if you don't know what a sync block is right now, don't worry. It's just a standard. It's like the simplest type of block you can have. And -L is the language. I want to write it in C++ because I'm jazz and whatever. And I'm going to call it square, FF. Why do I call it FF? Who knows? I think I heard the right answer. Sorry? No. I think, unless I misunderstood. So it just means we take float inputs and we produce float outputs. There we go. And it'll ask me a couple of questions because I didn't specify everything at the command line. So we do have some kind of user interface. It's just on the graphical one. Do I want any arguments? No, I don't want any arguments. Like square. Squaring doesn't require any parameterization. So let's do that. Do I want Python QA code? Oh yeah, that sounds great. Let's do that. And do I want C++ QA code? Nah, not really, because I already have the Python QA code. There we go. And so there's my block. I just need to fill it with life. And something I also need to do is I need to make sure that my compilers know what to do at this point. So I'm going to create, let's give it the right name. I'm going to call it build. Go there, and then I need to run a CMake. So CMake is a tool that sets up compiler environments, etc., if you're not familiar. And you just need to tell it, for example, where to install stuff. And I install all of my GNURadio into this folder. If you're just using a system default, you don't even need that. And it'll sort of try and figure out what's going on my computer, and then it says, okay, that's fine, you can compile. And I'm very happy about that. So, I'm sorry?
What's the difference between CMake and make?
So I also need make. I need CMake to set up make, basically. That's like the gist of it. Okay, so let's go into here. So I'm gonna actually open this file. And this file, oh no, I need bigger fonts. Damn it. Does anyone know how to increase the font size? Can you actually read that? Maybe I'm being a bit paranoid here. It's good. Oh, okay, good. Okay, so how do we write a unit test for a block? Well, we know that it's something that takes in numbers and then outputs squared numbers. That doesn't seem too difficult. So first of all, I need something that produces numbers, and I'm gonna I'm gonna create a block that does that for me. So I'm gonna create a block that creates numbers, and it's called vector something, I can never remember. But it doesn't matter because this is all Python, it's very easy, and my IDE will be able to help me with tab completion. So there we go. It's something source f because we want floats. And if I can't remember the arguments, not a problem. I'll just ask Python for the doc string, and it gives me this explanation what to do. No remembering required of any sorts. So I need to put some data into here. Where do I get that? Well, I need to define it, obviously. So let's create some data. And I'm just gonna like 1, 2, 3 is fine. And if I put in 1, 2, 3, what do I want on the output? We can do that in the head. 1, 4, 9. No? So we create the data, and then we need, like, we want to test our block. There we go. And then we create another block, and we dump the data into that. And then the other block is something like messaging, no problem. I just use my tag completion, and I connect these blocks. Source, square, sync, there we go. And that's pretty much it. Now this was pretty fast, I admit. Like I'm not gonna assume that everyone immediately can follow everything I'm doing right there. But what I'm trying to convey is it doesn't take a lot of code to sort of set up a, this is actually a miniature GNURadio application. And its only purpose is to make sure that my block does the right thing. So I run it, and then what I need to do is I need to check, and then also function, oh, there it is, assert equal, that, where we are, that the output is what we expect. Expected. No. Oh, I misspelled it up there. Oh, I'm just gonna misspell it again. at least I'm consistent. Yeah. So if I run this, it'll fail because I haven't actually written the block, yes. So that's fine. Let's write the block. I'm sorry about that. There's several files I need to change for blocks, unless they're very simple, and this is a very simple block. So I'm just going to open the one that I need. Now this is all generated code by gr-modtool. You can see there's nothing. There's a lot of stuff that I would have, I don't have to type now because it's already there. And one thing that's in there are these little jump markers. For example, this one. So I have my editor set up to jump straight to these points in the code where I need to change stuff. So this makes it very, very easy to find things. Also, when you forget to do it, it just won't compile, and it usually is quite obvious what you need to change. So for example, here, it's asking me for a minimum number of something, and that something is the number of input ports we have. So this is 1, this is 1. Input type is float, not a problem. 1, 1, output type is float, there we go. And we need to define some buffers. Let's define float buffers because that's what we're using. Let's change that. And then we have this infamous line, do signal processing. So if gr-modtool could just write that for us, that would be so great. But unfortunately, at some point, we do have to use our own brains, and this is where it is. But don't worry, this is pretty simple. We want to correct something. So what do we have here? We have a buffer of input data, and we have a buffer of output data. So what we want is we want to write the square of this value to this buffer. That seems easy. So let's create a for loop, and we actually have this number of samples available. And this is something that you have to look up the manual. So it's a function parameter passage here. And it's that. And we know the output at index I equals in at index I multiplied by index I, because that's how we square it. Blah, blah. That's it. My first block. So let's compile it. Ta-da! And takes a bit because it's the first time I've compiled my module. Let's see if it works. Hit my F5 button, which I've set up to run test, and it passes. And how do I know it's actually really working? Well, let's just multiply this by 2, and then obviously it'll fail if I recompile, just to show you that I'm not actually cheating or anything. And there we are. And it actually tells us why. Like, oh look, they're all the outputs are multiplied by 2. That's wrong. Well, yeah, that's what I was expecting. Okay, that's it for the block. And I've gone over these things pretty quickly, but I would like to argue that this is actually not that difficult. So let's say I'm running something more complex than a square box or something like convolutional decoder, for example, then obviously these lines would be more complicated. But I do not have to worry about setting up buffers or data transports, or like maybe my test vectors are coming in through through the air over an antenna. I'm using a USERV, for example. I just use stuff that's already in GNURadio to write all of it. So okay, I'm running one more time. Okay, I have a second part to this coding that I'm going to skip, where I actually ask the audience for ideas on block and then implement them in real time. And that actually worked out fine the time spectrum. But I'm afraid I'm going to have to go ahead with the rest of my talk here. Are there any questions on this part until now? Yeah?
Which cyber spectrum did you do the presentation in?
Oh, that's a good question. It was the one in March. I don't know, like, the number of the site, because Braun has them listed by number. Might have been the 5th one, but it was definitely one in March, yeah.
Will this block show up in the...
Fantastic question. Let's see, okay. Square? Yeah, nah, it's not here. Well, why not? Well, I haven't installed it. So there's actually a tool that I can use to create the GRC bindings. And it's not, for simple blocks it works. It's called Square, there we are. So it asks me if I want to create GRC bindings with Square. Oh yeah, that's fine. I just wrote that. That's good. Let's install it. Go here. I need to reload my blocks. That's what this icon does. And you can see we have con all of a sudden. There we go. Square. Actually, let's give it a spin. I'm feeling adventurous here. So let's create a, I don't know, sine wave is fine. And square that into a scope. And this kind of thing, Tom, are you talking about the scope with Tim? Someone is talking about graphics in GNURadio. So there'll be a big presentation on that, so I'm just going to sort of show that this block actually works. Oh no, I need throttle. There we go. So there we go, save that flow graph. And something's going, oh, it's already up in the background, there we go. Oh, it's the same dialogue. I'll just do it anyway. Okay. Run it. And so it's green on black. I can see it. Oh yeah, that will work. Also I can zoom in here. See, data, let's change the line style, sorry, the line width to 10. There we go. And you can see it's between, I can actually add a grid as well. And you can see it's between 0 and 1 because we squared it, so it's working. Okay? Any other questions?
Is there a similar sort of tool to create a recipe to integrate it with PyBombs?
No, but making recipes is very, very easy. So they have like a couple lines, text files. You can take an existing one and just change the parameters you need to change. Actually, that's, maybe we will add that at some point. But the thing is that we maintain the recipes ourselves. It's, what you can change is what we call a manifest file. Where is it? There we are, manifest. So this is something that you can edit. And I can sort of, I don't know, like, hey guys, gr-con is awesome. And this is what will appear on CGRAN. So I can link an icon, that kind of thing. And as soon as it lands in PyBombs, this file will be passed to generate the CGRAN file. So there's that. Do we have more questions?
What does this purpose block do?
It makes sure that my flow graph doesn't explode, basically. So my computer will try and run this as fast as it can, unless there's a throttle block. That's the short answer. Okay? Okay, that's a couple more minutes. So yeah, so that's gr-modtool. That's how you write blocks. And you can also write blocks in Python. And if you have no experience with Python, let's say you know something like MATLAB, Python is really easy to learn. So if you've managed to learn MATLAB, you'll be able to learn Python. It's the same level of complexity. The difference is that you can actually write big applications without having a messy code base. Plus, it works with GNURadio, so that's another advantage. Yep. So you can't write blocks in Octave, that doesn't work. But you can do stuff like write data files with GNURadio and then analyze them with Octave. A lot of people do that. But Octave doesn't follow the streaming paradigm that GNURadio does, so it doesn't really make sense. I guess you could somehow write something that lets you write blocks in Octave, but no one's ever done that. And because
I think that has been done.
yeah.
I think people have done it with MATLAB.
Yeah,
Octave should be fairly similar.
it would probably be even easier. But what I said earlier still applies. You have all the SciPy and NumPy extensions to Python. You don't really need Octave anymore. Okay? Yeah?
Suppose you write code in log in Python. Does GNURadio take advantage of the CMD?
CMD extension. Yeah, actually it does, because if you use NumPy, which is the numerical Python, like its backend is written in C and it's pretty fast. So so intuitively you think like if I write something in Python, it'll be way slower than in C++. That's not necessarily the case. Because NumPy commands like add and subtract and they're pretty fast themselves. Whereas if you use C++, you have to manually instantiate the full kernel to get the acceleration out of it. That said, if you want performance, you usually prefer C++ because you just have more options to optimize and direct memory access, all those things. Okay? Okay, I'm just gonna move on. So yeah, gr-modtool and block writing is sort of like the core component of developing with GNURadio. And we tried our best to make this both accessible and well documented. And only when you sort of start moving into the actual realm of developing within GNURadio itself, that's when it sort of gets more difficult. Now, a good question, like, I made this example where I said, well, if you write a convolutional decoder, it's more complicated. And then you might ask, yeah, well, so how do I write a convolutional decoder? Like, how do I learn all these things? Like, how do I write a digital modem? And at that point, it gets a bit more difficult. So you can read lots of books, or you can get a degree in digital comms. At some point, digital communications is simply difficult. And it's not something you can just get any tool to do for you. So one thing you can do to learn about DSP is just ask Jeff, who's doing the next talk. But otherwise, this is sort of, like, the tools can only do so much for you. This is sort of the point where you sort of need to think about things and invest some time into learning how to do that. So I tried explaining like the whole development chain of a GNURadio block within like half an hour. I could have done the same thing with forward error correction to a similar level. But not to worry. First of all, you don't have to know all these things to get started. You can sort of learn gradually one at a time. Like maybe you know what a forward error correction does, but not how it works. Doesn't matter. You just grab the blocks in GNURadio, put them into your application, and focus on something else. And even then, you can always ask people. And we have the mailing list. And there's the discuss GNURadio, the mailing list. There's also a lot of GNURadio discussion on user users, which is the edit mailing list for. It's mostly for user-ups and stuff, but people can ask anything software-defined radio related. And there's a lot of traffic there, and people will answer it. There's a high chance that someone called Marcus will answer your email. And there's also the GNURadio channel on Freenode. There's this one. Hey guys, you can start a chance to write something. Yeah. Yeah, this might be not appropriate. Yeah. And we obviously have the wiki page that is maintained by the community. And let's say you actually want to become a GNURadio developer and want to start contributing like anything. So you can just fix bugs, but you can add features, you can just add documentation. We're very happy about documentation patches. The difficult thing about writing documentation is when you have a lot of experience in something, you sort of lose what's relevant to beginners and people who are new to the field. So while you're learning these things, that's a good time to write documentation and then submit it upstream to us so we can merge it into GNURadio. Like even if something's badly coded, you can send a patch on it. And then that might actually improve the project because the source code is what we deliver to people. It's not just GRC as a block. The community is something I just want to highlight separately. So you do not have to do any of these alone. And if you're running out of stuff to wear, we have a web shop. Actually, I have that open here. So this is what which one is it, dude? It's very black on the screen, I'm afraid. But you can buy shirts and sweaters and track pants and baby bibs and flip-flops and unfortunately the GNURadio ties are no longer in stock. So. Who owns the GNURadio tie except for Tom and myself? Ha! We good up there. Yeah. Just a couple of pages I'd like to highlight if you want to sort of join the community. That's the mailing list page, explains what you need to do to sign up. And also we have this page that sort of, if you're new to mailing lists, like I recommend reading this. I strongly recommend reading this. It just sort of gives you an idea about how to interact with people because often it can be a bit intimidating asking questions. Don't worry, you can ask questions, but it does help if you read this beforehand. It just increases the chance of you getting a useful answer. And I really don't mean this in a patronizing way. This will actually help you get your answers quicker. And also we have a separate page that explains what you need to do if you actually want to become a contributor and start patching GNURadio or whatever. Okay. Apart from that, there's a couple of local meetings, and we have this conference obviously, but there's also stuff going on in Europe, and there's Hackfest, and so Michael Osman, for example, he does a bi-monthly meeting in Denver, I think. Stuff like that is happening all over the planet, and I do encourage you to participate. Yeah, that's all from my side. Thank you very much.
Awesome. So we finished up just on time, but if there are any last minute, some quick questions, these were questions for us, so that's good. Okay. Well, great. Thanks, Martin.
So this guy had a question.
Oh, yeah, sorry.
So in our particular application, we have a very simple transmitter actually transmitting an ID, probably 1,000 bits. We wanted to make the GNURadio standalone rather than we have to attach a computer all the time with it for that simple kind of functionality. Is there a less painful way of doing that rather than go through the whole FPGA process?
Okay, so that's a really good question. It's probably best asked on the mailing list or answered offline, so I can talk forever about this right now or sure. I think
Just
there's...
point out the embedded work that we're doing, because that's more.
Yes, actually, can you grab the mic and say something about that? You're probably more qualified to talk about that.
Yeah, so the question being, do you need a whole computer attached to the front end or whatever? We are working a lot on embedded radio, embedded system development. So single board computers, there's the E310, there's other radio hardware out there that comes with an ARM processor, a Zing chip on board, ties directly to it. Or like I said, a single board computer, and I showed this last year in my talk on radio front ends where I had a hacked RF, a B200, and an RTL SDR plugged into the same Odroid, which is not that big. And that's a deployable solution to do those kinds of comms. So that's where we're focusing a lot of our attention right now is on that kind of single board computer matching with the radio front ends. So it's still kind of the same setup, just much smaller. All right. Thanks again, Martin.